Good afternoon, everyone. Thank you for coming to this presentation of the new French forecaster workstation, Synopsis. First, let me start by introducing myself. So my name is Lisa Marchand. I'm working at Météo France in the production department, and I'm a functional lead of the Synopsis team.
Hello, I'm Hugo Vandeput, and I work at Météo France at the IT department. I'm a technical lead of the Synopsis client software. So we will present you some reminders about Synergie and Synopsis projects. After that, Lisa will present you some features of the software. And finally, I will present you some technical aspects of the software. So Synergie is a forecaster workstation. It was developed during 20 years. And at the beginning, it was developed using X-Motif technologies and Solaris Unix and Oracle database technologies. After a while, it was ported to Linux and PostgreSQL database. And the last components were developed using Java and Java Swing technology. So the system began to be a little old and difficult to maintain, and we had to develop something new. Synergie was widely used in more than 200 working positions in Météo France, and the same number abroad in more than 60 countries. So the goal of Synopsis, of the project Synopsis, was to replace Synergie. And it was a very risky and ambitious project because we had to replace something that was used by generations of forecasters. And we had to develop a completely new architecture based on services. The project is not over. We have one more version to deliver this year, but it's massively deployed in operational and used by more than 200 people every day, and we have more than 1,000 users on occasional basis. So now let's talk about the functional part with Lisa.
Thank you, Hugo. So as Hugo said, Synopsis is powerful and provides a lot of functionalities, but I would like to start with the common one. The first one is that Synopsis is interoperable with use of web services. It has what we could call Google Maps-like spatial navigation with zooming and panning. Because of the increasing of the amount of data, Synopsis offers an adaptive catalog and provides the best data set according to the validity date, the process, or the product. The graphical user interface is customizable. And the last but not the least, because very important for our forecasters, there is a continuous link between past and future data. Now that we set the basis, I would like to start with the new features, but first, in order to respect the main topic of this conference this year, I would like to give you a brief overview of how we manage the observation in this software. So we have what we call a table of observation, which permits to monitor our favorite station and favorite parameters, and to have details with some table or some other representation like meteograms. So now let's start with the new features. Today I decided to show you two new features with a short video. So the first one is the shared layer. So here you have to imagine that we have two different forecasters in two different meteorological centers. The first one is the upper part of this window. Decided to add a drawing layer in order to draw some objects, for example, simple line, just like that, or some meteorological objects like fronts, for example. The first forecaster will share this layer for read and write. The second forecaster, in the lower part of this window, will add what we call a share layer, and it will find the first one that we just created before. As you can see, the objects are reported on this second layer, And here we are we can move and we can modify the object, and it will be reported directly in the second window in real time. The second forecaster can also decide to modify this layer, and it will be also reported in the first window for the first forecaster. So all of this permits to forecaster to have a collaborative work in different centers, and at the end to produce some final documents for other forecasters or for customers. The second new feature that I would like to show you today is the field modification. So here we have a sea level pressure field. We can manage the intensity of the effect or the diameter of the effect. And here there are three main actions. The first one is to smooth the field. So as you can see, the lines are smooth here. We can also decrease a low-level pressure system, as you can see on the video, or at the opposite, to increase the high-level pressure system. The last action that we can do is to copy and paste the center of action in another place of the map. Like that. So it permits to forecasters to adjust their analysis to the field and to modify the field in order to produce some documents for other forecasters. So now that we saw the new features, I'm sure that you're very excited to know what is behind all of that, so I'll let Hugo talk about the technical part.
So the Synopsys software is based on a service-oriented architecture, where forecasters use an advanced Java Swing client. The client requests the server using WMS protocol, but the server is fully WMS compatible, but we use some specialized protocol to provide optimized service. So for example, the request get capabilities has its response encoded in binary format using protobuf code. On the server side, the requests are handled using microservices. We will see some details later. So we use a centralized server, and there are pros and cons for this organization. For example, some cons are that we need to have a good network to provide responsiveness. We need to have low latency, for example, and we need to have backup for our network and for our server. On the pro side, we can see that we do not have to broadcast raw data, so it's interesting because of the increasing size of this data produced by supercomputers. We can have a huge shared cache on local side, server side, and that's interesting for us to cache decompressed grids and to handle, for example, cross-section. We can have a powerful cluster of computers which provide horizontal scalability. We use a decentralized client, so it's interesting because users can access the software from everywhere, on every workstation, and we can provide local configuration. For example, the profile of the user is requested using LDAP protocol, and the preferences of the user are stored on a system, on a storage system, Amazon-like, Amazon S3-like bucket system. So that's cloud storage for our preferences. At the opposite side, on the local side, we can use local cache and CPU for better performance. And for example, we have user profiles that configure the workstation depending on the user's activity of the moment. Each map is a collection of layers. And when the user moves his maps, we have many requests sent to to the server, one request per layer. And on the server side, each request is handled by microservices, which call other microservices and so on. So we have to manage pools of thread on the client server side, on the client side, sorry. And on the server side, we use massive parallelism based on the cluster architecture. So collaborative production is handled using, for example, XMPP protocol. So every shared layer is a chat room on the XMPP server. And when a user produces something, it's stored on the bucket storage. And so it's shared between different users.
To conclude, SYNERGIE is a great success and very well accepted by our forecasters. The last operational version will be deployed in April this year, and it will replace SYNERGIE at Météo France. For the next, the software will be deployed for the Army and for customers abroad. And there is a study to use the architecture components in order to provide a unique platform for visualization and production tools. Thank you for your attention. If you would like to have more video of the Synapse system, we create a QR code and you'll have access to a YouTube channel. Thank you. If you have any questions, feel free to ask.
Lisa and Hugo are absolutely on time. We have time for some questions.
As far as highly evolved from data like radar data, what kind of performance do you get from loading data onto the screen?
It's lower than 1 second to load the image. And we have a network that's not very good. We have up to, I think, 4 megabits debit, so it's good.
What was the greatest challenge in getting your forecasters to adopt it? Easy? Was it hard?
The younger are very use it very naturally, and the older ones they can access new data, something that they were waiting for long. So it was the good aspect of the new software, and it was very easily accepted.
Thank you again.